Welcome students, myself Mehboob Pasha, and today in this session we are going to start one of the chapters of NCERT 9th standard science, that is motion. Okay, so we are going to start today in this class. We are going to start the chapter that is motion. So students, in a simple way, okay, so in a simple way, what is a motion? In your lower classes you might have studied that in general motion is nothing but movement of any object. Okay, so motion is nothing but movement of any object. Students, if you observe carefully, okay, so if you observe carefully, then we will come to know that most of the things in universe are set in motion. Okay, so most of the things in universe are set in motion. So for an example, earth revolves around the sun, so revolving also a motion, no? So earth revolve around the sun, as well as moon revolve around the earth, and the sun revolve around its own axis. Okay, so here day and night causes due to the rotation, due to the movement, due to the motion of earth. Seasons are also caused due to the rotation and due to the motion of earth. The train will move in a track. Okay, so the bus will is moving in the road. So all these are examples of motion. Okay, so for example, you might have seen clock. Now you might have seen clock, the hands of the clock, are set in motion. Fan, you might have seen fan also, no? So fan, when you switch on the fan, what it do, it starts rotating. So okay, so that is also an example of motion. So there are so many examples of motion. Even we will breathe out carbon dioxide. Okay, so we will breathe out carbon dioxide, and we will breathe in oxygen. We will breathe out carbon dioxide and we will breathe in oxygen. So here in our track air is moving. If this movement doesn't exist, means so we will be dead. No, so motion is an important. Okay, so motion of air is important. So here the blood is flowing in the arteries. Okay, the blood is flowing in the arteries. So these are the examples of motion, students. Still there are a lot of examples. Okay, so these are some of the examples of motion. So sometimes what happen, we are unable to see motion of a certain things. Okay, so sometimes what happen, we are unable to see motion of certain things. We will just feel that, okay, for example, movement of air. So how will come to know that the air is moving? How will come to know that the air is moving? Whether air is having any physical nature, where air is having any color and all? No, air is not having color and all. Then how will come to know that the air is moving? It is because we will come to know that the air is moving by the movement of dust and by the movement of leaves of the trees. With this movement, we will come to know that the air is moving. Students, so when you carefully observe the wall, okay, so when you carefully observe the wall, so look at it. So wall is not moving, no? So wall is not moving, but wall is made up of what? Bricks. Okay, and this bricks is made up of what? We have learned that. Okay, so each and everything in the nature, okay, each and everything is in the nature is made up of atoms. So each and everything in the nature made up of atoms. So what happens? Have you carefully observed the structure of atoms? So what is going on in that? Okay, so even in an atom, so what happening? The electrons are revolving around the nucleus. Okay, so electrons are revolving around the nucleus. So in the universe, in the nature, most of the things are set in motion. If it is at rest, we cannot say that it is at rest. So for example, I am standing here. Okay, so I am standing here. It doesn't, you cannot tell that I am stationary. Okay, so here the blood is flowing in my body, the blood is in motion, and the air is moving in the track. It is also in the motion. So, okay, so these are some of the examples of motion. Now students, we will see how the motion has been described. Okay, so how the motion has been described. So how will come to know that whether the object is moving? Just think. We will come to know that the object is moving by the position of a particular instant. Okay, so we will come to know that the object is moving by its position at a particular instance. So by knowing the position of an object, so we will come to know that the object is in motion or not. Okay, as I told you, okay, so as I told you, the movement of an object, the movement of an object is described by its position. The movement of an object is described by its position. Then how its position is described? Okay, I told that the movement of an object is described by its position. Then how the position of the object is described? How will come to know that the position of this body is here or there and all? How the position is described? Okay, so for this let us take an example. Now let us take an example for describing the position of an object. Okay, if someone asks you where is your school, then you cannot say that our school is 2 kilometer in north, okay, or 2 kilometer in south. You cannot say that our school is 2 kilometer in north and 2 kilometer in or 2 kilometer in south. If you say like this, okay, if you say like this that our school is 2 kilometer in north or 2 kilometer from south, then they will ask you. Then they will ask you from where it is 2 kilometer. Okay, from where it is 2 kilometers. So here, look at here. Here railway station is there. Here railway station is there. Here school is there. Suppose the distance between two things, that is school, railway station and school, is what? 2 kilometers. Then how will you determine? So how will you describe? How will you describe the position of your school? How will you describe it? You cannot say that the school is 2 kilometer. So here, to describe the position of any thing or any object, to describe the position of anything or any object, you will take a reference point. Okay, so we will take a reference point. So here, this is the reference point. Okay, so railway station is the reference point. Then you will say, if someone asks you where is your school, then you can say that the school is 2 kilometer in north, okay, from a railway station. The school is 2 kilometer in the direction of north from railway station. Like this you can specify. Okay, suppose let us take one more example. So your uncle is coming to visit your house. Your uncle is coming to visit your house. He has came to town in which you are living. Okay, so he has came to the town and he will ask you, where is your house? He will ask you, where is your house? At that time, what you will say? Will you say that my house is 10 kilometer? Will you say that my house is only 10 kilometer, or will you say like this, my house is 10 kilometers in the direction of north, or my house is 5 kilometers in the direction of south, or my house is 3 kilometers in the direction of east? Will you say like this? If you say like this, then your uncle will ask from where it is 3 kilometer, 4 kilometer or 5 kilometer. Your uncle needs a reference point. Okay, so your uncle needs reference point to determine the position or location of your house. So here what you can say? You can say that, uncle, my house is 5 kilometers in the direction of north from railway station, or uncle, my house is 10 kilometers in the direction of south from bus stand. Okay, so in this way, with the reference point, you can specify the position of an object or thing. So here in this case, railway station is a reference point. Okay, so you cannot say that my school is 2 kilometers, 3 kilometers. You can say that my house is or my school is 2 kilometers in north from the railway station. What is railway station here? Railway station is a reference point. Okay, so why we are using this reference point? We are using this reference point to determine the position or location of the school. Okay, so remember one thing, to determine the position or location of any object or anything, you need a reference point. Without reference point, you cannot determine or you cannot locate the position of any object or any thing. Now students, we shall see what is motion along a straight line. Okay, so what is meant by motion along a straight line? So generally, what is motion? Movement. Okay, so generally what is motion? Motion means movement. So movement of an object along the straight line is known as motion. of an object along a straight line. Okay, so movement of an object along a straight line is known as motion of an object along a straight line. So imagine there is a straight road. Okay, so imagine there is a straight road, and if you are moving on that road, so we can say that your body is moving, no? So your body is moving, so we can say that motion of an object along the straight line. Okay, so here the road is straight, no? So we can say that as you are moving on that road, so we can say that the motion of an object along a straight line. So okay, let us see here. Okay, so if the object is at O, if imagine here there is a person. Okay, imagine there is a man standing at the place of O. Okay, so this is a reference point. What is this? O is a reference point. It is a reference point. So here the man is traveling in a straight line. The man is traveling in a straight line. So at first he comes to C, then from 0 to C he will comes, then next he will travel from C to B, again he will travel from B to A. Okay, so he will come from O to A. He will come from O to A. During this instance, okay, during this time, how much distance has he covered? How much distance has he covered? He has covered 60 kilometers. Okay, so here if he comes from O to A, if he comes from O to A, then what does it mean? He has covered a distance of 60 kilometers. Okay, so look at here. Distance covered. How much distance has he covered when he moves from 0 to A? When he moves from 0 to A, he has covered a distance of 60 kilometers. Okay, so he has covered a distance of 60 kilometers. If the object or if the man is moving from 0 to A, okay, so if he has moved from 0 to A, then how much distance he has covered? Okay, he has covered at a distance of 60 kilometers. Okay, if he moved from 0 to A, then what does it mean? It means that he has covered a distance of 60 kilometers. Okay, so now what is the displacement here in this case? What is the displacement here in this case? Before that, what is meant by displacement? What is meant by displacement? Okay, so displacement is nothing but the least distance between the two points, that is initial point and final point. The displacement is nothing but the least distance or the distance. Displacement is nothing but the distance between the two points. So here this is a final point. Okay, in first situation this is a final point, and which is the initial point? Initial point is O. Now initial point is O. He has started his journey, okay, from O, and he has ended his journey up to A. Okay, so initial point is O and final point is A. So what is the distance between O and A? What is the distance between O and A? 60. Now look at here, there 0 and here 60. So the distance between, so there O is initial point and A is final point. So the distance between initial point and final point is what? 60 kilometers. That's why in this case distance covered is also 60 and displacement. Displacement is also 60 kilometer. Okay, so in this case displacement is also 60 and distance covered is also 60. Now let us imagine the second situation. So here the man is in second situation. Okay, so the man is traveling from O to A. Okay, so he is traveling from O and he has reached at A. Now after reaching at A, then what he will do? He will move back. And comes at C. He will move back and comes at C. Okay, the man has started his journey at O and he has moved up to A. And when he come at A, okay, so when he comes at A, so what happens? Then he will again moves to C. Again moves to C. So now here, what is the distance covered? So in this case, in second case, what distance covered here? What distance has he covered? So look at here. Okay, look at now. What we are calculating first, we are calculating how much distance has he covered in the second case. So here he has come from O to A. Okay, he has come from O to A. That is, first how much distance he has covered? OA. Okay, so he has covered a distance of OA. Next he has moved back now. Again, from where he has moved back? From A to C. Again he is moving back from A to C, and he stopped at C. So again he has covered a distance of AC. He has covered a distance of AC. So OA is the one distance and AC is the second distance that he has covered. Now, what is OA? Look at there. It is 60 kilometer now. OA is 60 kilometer. Next, OA is 60 kilometer. Now AC. Okay, so what is AC? Look at it. How much AC? This each divide represents the 5 kilometer. So 5 kilometer plus 5 kilometer plus 5 kilometer, 15 plus 20 plus 25 plus 30 plus 35. Okay. So here what is AC? AC is 35 kilometers. Okay. So 5, 10, 15, 20, 25, 30, 35. OA is 60 kilometer and AC is what? 35 kilometers. So now in this case, how much distance he has covered? He has covered a distance of 95 kilometers. Okay. So how much distance he has covered? He has covered a distance of 95 kilometers. So now what is displacement in this case? What is displacement? As I told you, displacement is nothing but the least distance between the 2 points, that is final point and initial point. So here in this case, so this is a initial point and this is a, okay, so here in this case this is a initial point. So what happens in this case? The man travels from O to A. Okay, in this case the man travels from O to A and again he moves back to C and again he comes to C and stop his journey. Okay, so he moves from O to A and again after reaching A, again he comes back to C and there he stops. So here in this case the initial point is this one, that is O, and the final point is C. Okay, so the initial point is O and final point is C. So look at here, what is the distance between these 2 points? 25, no? That is 5, 10, 15, 20, 25. Okay, so the distance between these 2 points is how much? 25. So what is displacement in this case? Displacement is what? Displacement is OC, no? OC, that is, what is how much OC? 25 kilometer. Okay, so in this case the displacement is 25 kilometers. So now we'll see. Okay, so in this case you will see the what is the relation between distance and displacement. Okay, so now we'll see the relation or difference between distance traveled and displacement. So look at it. So now we'll imagine, now we'll take, okay, so now we'll consider the motion along a circular path. So the motion along a circular path. Okay, so this is a circular path now. So this is a circular path or circular way. Okay, now the diameter of this circle, the diameter of this circular path is how much? 14 meter. Okay, so the diameter of this circular path is 14 meter. So now let us imagine the man is standing at the place A. Okay, he is standing at a point A. So now he moves from A. Okay, he moves from A and stops at C. he moves from A and stops at C. Initially he is at this point and he has moved from here to here and stopped at a point C. So now, what is distance traveled and displacement in first case? Okay, so this is the first case, case 1. So now what is distance and displacement in this case? So look at here. This is a circle now. This is a circle. And this is semicircle now. This is what? Semicircle. So here, to find the distance what that he has traveled, so what we need to do? So we need to take first circumference. So this is the circumference now. Okay, so we need to take first circumference and we need to divide that circumference by 2. Why 2 means? Here, because he has covered only half track. He has covered only half track, not full track. Okay, so first we'll see circumference. 2 pi r. So it is 2 into 22 by 7 into, and if the diameter is 14 means what is r? R is what? 7. Okay, if diameter is 14 means r is 7. So 7 in the 7 are cancelled. 2 into 22 is 44 meter. Then what is total circumference? 44 meter. But how much he has covered? Only half of the circumference. He has covered only half of the circumference. That is 44 by 2 is what? 22. Okay. So 44 by 2 is 22. Then what is this distance? This distance is 22. So here distance traveled. Okay, then what is the distance traveled by the man? Okay, so he has traveled a distance, or he has covered a distance of 22 meter. Okay, so he has covered a distance of 22 meter. And now what is the displacement? So what is displacement in this case? Look at it. I told you that displacement is the least distance between the 2 points. So this is one point and this is one point. This is a initial point and this is a final point. So here, what is the distance between these 2 points? Least distance 14. No, the distance between these 2 points is 14. So here displacement is what? 14 meter. Okay, so displacement is 14 meter. Remember, each time distance covered or distance traveled is not same as displacement. Distance covered or distance traveled is not same as displacement. Okay, so displacement can be 0. Displacement can be 0 but not distance. Displacement can be 0 but not distance. We'll take one more example. Now we'll see second case. Okay, so now we'll see second case. Okay, look at here. The man is standing at A. So this is the initial point. So here what he does, he will cover a full circle. He starts his journey at A and he will move through C and again he comes to A only. Again he comes to A only. Look at here. The man has started his journey at point A. He is moving like this. Okay, so he has arrived at C and again he don't stop here. He has not stopped here. Again he moves through C and comes at A only. Again he moves through C and comes at A only. So here he has covered a full circle. He has covered a full circle. Then what is distance traveled in this case? The distance traveled in this case is what? As, look at here. As he has covered a full circle. He has covered a full circle. The distance traveled by the person is equals to circumference of the circle. Okay, the distance traveled by the person is equals to circumference of the circle. The distance traveled is what? It is equals to circumference. And how much? What is circumference? 44 meter. Okay. So in second case, the distance traveled by the person is 44 meter. And what is displacement here? What is displacement? Look at that. He has started his journey at A and he has ended his journey at A only. Okay. So here in this case, initial point is A only and final point is also A only. Then what is the distance between A and A? 0, no? There is no distance between A and A. Why? Because initial point is this only and final point is also this only. The 2 points will overlap. Initial point and final points will overlap. Then what is the distance between 2 points? No. There is no any distance between 2 points. So here in this case, displacement is what? 0. In this case, displacement is 0 meter. So remember, displacement can be 0 but not distance traveled. Okay. So I hope you might have understood these concepts.